Welcome, everyone. So this is Secondary Math 2, and we're just starting right up with Unit 1.1, Classifying Polynomials and Distributing. All right, so in class, last time we talked about what does poly mean. Okay, poly means, right here, many. Poly means many, so many terms. All right, so we need to talk a little about the terminology. So if we have a coefficient is all of the numbers in front of the variables. Okay, so before I do this, let me write down an example. And I want to do the same example we did for everywhere else. So let me just grab that really quick. Okay, so in class we used the example of x to the fourth minus 2x cubed plus 4x minus 9. Okay, so here's our example of a polynomial. It has multiple terms, and we'll talk about what a term is. Okay, so a coefficient is all the numbers in front of the variables, including, you include the sign. So for example, we have -2, that's in front of a variable. 4 is in front of a variable. -6 isn't in front of a variable, okay? And we're missing one more. If we don't see a number in front of a variable, that number is going to be 1, okay? So there would be like a 1 here, right? So we have three coefficients, 1, -2, and 4, okay? Constant is all the numbers that are not in front of a variable, all right? So for this one, the constant would be -9. And again, we keep the sign. We include the sign. Terms is numbers and or variables separated by the pluses and minuses. Okay? So for example, let me change my color. This would be a term. Let me erase that one. Right, so that would be a term. This would be a term. This would be a term, and this would be a term. So here for our four terms that we have, the terms would be x to the fourth, -2x cubed, 4x, and -9. Oftentimes on the homework and the test, they may also ask you the number of terms. Okay, so the number of terms would be 4. We just count how many terms there are, and there are 4 terms. Degree is the highest exponent. So if we look at this, we have, this is a term, this is a term, a degree, an exponent. Here's an exponent, exponent, exponent. Here would be 1, and here we wouldn't have an exponent here. All right, so we want to look for the highest. The highest exponent here would be 4. And then polynomial, an example, we just have it here at the top. Okay? So let us learn about how we classify polynomials. Okay? Polynomials can be classified by the number of terms or the degree of the polynomial. All right? So in class we talked about one term would be called a monomial. Okay? An example of that would be something like x or x squared or 2x or 5x squared. Those are all, if that was your problem, it would just be a monomial. Okay, if we have two terms, that's called a binomial, meaning 2. So a binomial would be something like x plus 1 or x to the fifth minus x squared. Those would be binomials, one term, two term, one term, two term. Okay, 3 terms would be a trinomial, something like x to the 9th plus 2x to the 5th minus 1. Okay, we have 3 terms, and that would be a trinomial. We don't look at the degree or the exponents, just how many terms there are. If there are more than 3 terms, we just say it's a polynomial with, say, 5 terms or 6 terms. A polynomial with some number of terms that you have that you counted. Okay. We also classify by degree. All right, so last year in secondary 1, you learned about equations like this, y equals mx plus b, okay? That is a linear equation. When you graph it, it makes a single line, all right? That is a linear equation. So if you have the highest exponent, which is 1, right, or if it, obviously, we never show that we have x to the 1, but that's really what it is. So anything that has x to, and we don't show the exponent, that is linear, okay? So for example, something like negative 2x plus 5, or just, another example could be 3x, okay? Or, okay, yeah, that's good. All right, quadratics, whenever you have the highest exponent of 2, okay? And this year we're going to be talking a lot about quadratics. So an equation like this would be y equals ax squared plus bx plus c. All right, and we'll be learning about that a lot in the future. Okay, cubic, the highest exponent is a 3. All right, so anything like 2x to the 3 plus 1 or something like this, that would be a cubic because it has the highest exponent of 3. Anything greater than that, so say, for example, you had x, well, let's look at the example we had at the top. Here our highest exponent is 4. So what we would say, it's a 4th degree polynomial, okay? Or if it was x to the 10th, it would be a 10th degree polynomial. Okay, so these terms just and degrees, just kind of have to remember monomial, binomial, trinomial, and for degrees, linear, quadratic, and cubic. And then what do you do if it's more than 3? Okay, all right, so let's do some of these examples. Whenever you watch these videos, please pause, give it a shot before I show you how to do it. You'll learn the most that way. Okay, so for this one, we have 2 terms, 1, 2. That's all they want is the number of terms. We don't want to list the terms, we just want the number of terms. List the coefficients. We have negative 10. Remember, negative 1 isn't a coefficient, it is a constant because it doesn't have a variable in front of it or after it. Okay. Classify by terms. Since we have 2 terms, that's called a binomial. And classify degree, it would be a linear, because our variable, our highest exponent would be 1. Okay. Next we have number of terms. We have 3. List the coefficients, negative 2 and negative 2. Constant would be 7. Classify by terms. All right, terms, we have 3 terms, so that would be a trinomial. And by degree, the highest exponent is 2, so that would be a quadratic. Okay, and sometimes they combine those together and call it a quadratic trinomial. All right, and next, how many terms? We have 4. List the coefficients, negative 6, negative 8, and 5. Constant 10. Calling by terms, this is a polynomial with 4 terms. Okay, because we have more than 3, so that's how we call it. And then by degree, we'd say it's a 5th degree polynomial. Okay. Next, we have number of terms. We have 1 term. Coefficient would be negative 1. Again, so if we don't see a number in front of a variable, it's just going to be 1. List the constant. We don't have any, so you could say none. And or if, I mean, you could say 0 as well, because we don't show the 0 that would be there anyways. Okay. And classifying by terms, since there's 1 term, that would be a monomial. And by degree, that would, since it's a 3, we'd call that a cubic. All right? All right. Next, we have the distributive property. Okay, so remember, whenever you multiply the number outside of the parenthesis, you have to do it to every term inside. So we'd distribute to the 1. 9 times 1 is 9, and then 9 to a negative 8x. That would give us a negative 72x. Okay? And it says, let's do the next one. It says include the negative if there is one. Okay, so here for b, we do have a negative. We need to distribute that negative 9, the whole thing. So that would give us negative 81n. And then we distribute here, we get a minus 72. All right? And one thing that I will ask you to, whenever we look at A, we always want to have it in order of highest exponents to lowest exponents. So here we'd want to write it as negative 72x plus 9. Okay? So we'll do that with C as well. So pause if you can, do the rest. I think it goes to the next page as well. And check your answers. So here we're going to distribute this negative 6. We still have this 4. We'll get a negative 54a, and then we'll distribute it to this negative 4 to give us a positive 24. And then we'll combine like terms. So here's a term. We don't have any other like terms, so we have negative 54a, and then we'd combine the next like terms, which gives us 28. Okay? And it's in standard form, highest to lowest exponents. Okay, next, we will distribute the 5 to get 15. Distribute the 5 here, gives us a negative 35x. And now we need to distribute this negative. Again, you could put a 1 there if you wanted to, just to make it simple or to understand it a little better. Negative 1 times 1 is negative 1. And then a negative 1 times a negative 6x gives us a positive 6x. And then we want to combine like terms. So we'll combine these like terms. That would give us a negative 29x. And then we'll do the next highest exponents. That would give us a positive 14. Okay. E. Distribute, same deal, and then combine like terms. F, distribute, all right, and then combine like terms. And again, make sure you have the highest exponents first and then the smallest. Okay, distribute 4p plus 12. And then we distribute the negative as well, negative 2, gives us negative 10p. And then here is where most people have mistakes, is they don't change the sign when we multiply a negative and a negative. That will give us a positive 6. Combine like terms, negative 6p. And then combine the next highest exponent, it gives us 18. Okay? All right, so that's distributing. Okay, function notation. This is new. All right. Last year you learned about equations like y equals mx plus b, or this example is 2x minus 7. This can be written in function notation. So instead of having like y, we're going to rewrite it as f of x, and that's how you call it, f of x. Okay? And then oftentimes they'll ask you for questions like find, for this one, find f of 2. All right? So basically what we're saying is that x is equal to 2. So we're going to substitute that in for our x value. So 2 times x, well, x is 2. Minus 7. That gives us 4 minus 7, which is negative 3. Okay? You may have something like this, f of x squared. Okay, same thing. What we're going to do is we're going to substitute that in for what x is. Right here, there would get 2x squared minus 7. Okay? All right, so let's do some of these examples. It says the distributive property works the same way as before, just like we did over here. Okay? You distribute to all the what's in the parentheses. Okay? Sorry, I brought it down. Okay? But the notation looks a little different. So for example, oftentimes you'll see it as kf of x, where k is some sort of constant, like a, where we have 5 times f of x. Well, all you're going to do, they give you what f of x is. We're going to substitute it in for that. So we have 5 times 3x plus 4. And make sure you put a parenthesis whenever you plug in a function. Okay? If you had it differently, then you wouldn't be distributing correctly. So that gives us 15x plus 20, and that would be your answer. Okay? Pause and see if you can do B, C, and D. So we have negative 3 times f of x. Well, f of x is 3x plus 4. And then we will distribute. Remember, we're not just distributing the 3, we're distributing the negative 3. So that gives us a negative 9x minus 12. Okay. C is 2 times h of x minus 6. So 2 times h of x. Well, h of x is negative x. Okay. If you didn't have a parenthesis there, then you may get confused and think you're doing 2 minus x. So this is one of the reasons why we want to have a parenthesis. Minus 6. So we distribute, and we get negative 2x minus 6. Next one, we have 2 times g of x. Well, g of x is 5x minus 1 plus 3. We'll distribute 10x minus 2 plus 3. Combine like terms, 10x plus 1. Okay, so that's it for the first session. I'll try and put ones on every time we do a class. Let me know if you like this. Like and subscribe. That would be awesome. Okay, thanks.